Hello everyone, welcome back to Portland Technical's video series on basic DVOM operation. In this video we're going to be exploring resistance testing. Now let's define what resistance is. In electricity, resistance is opposition to current flow. Now resistance is necessary to make a complete circuit. If we did not have resistance, current would overload and damage our components. So there is necessary resistance, or in other words a load, and then there can be unintended resistance that causes problems in circuits. And in this situation we're going to be looking at the possibility of actually testing both good resistance and unwanted resistance. So let's take a look at resistance and the DVOM first. Now, as a reminder, DVOM stands for digital volt ohm meter, and the DVOM will measure resistance by sending a small voltage and current from the red lead of the meter to the black lead. Now, this is very important to remember right here. This can affect your reading all the way around. Because it sends voltage and current down the leads, you must remove power and isolate the parts that are being tested. If you leave power connected to the circuit and the DVOM actually sees that voltage in addition to the voltage going through the leads, then that can give you a completely erroneous reading. So this is very important to remember. Got to remove that power and got to isolate the components. Now, the meter can measure very high resistances, all the way into the millions of ohms, down to less than 1 ohm. So there's a couple of things that we need to pay attention to. There are different values or value qualifiers that we might see on the DVOM, and they are mega ohms, or in other words large M ohms, kilo ohms, K with the ohm sign, and then the singular ohms qualifier. So in other words, if you just see a regular ohm symbol by your reading, then you will multiply that by 1. If you see K ohms, whatever your reading is, times that by 1,000. If you see a large M and an ohm symbol, times that by 1 million. So where will you see this value qualifier? Right here. Okay, on that right-hand side of the screen. So let's take a look at the different type of resistance tests we can do. First one is going to be continuity tests, or in other words, a go, no-go test. In this test, what you're going to be doing is actually checking things like conductors and wires to make sure that they can actually carry current and voltage from one end to the other. The second type is a resistance test with a specification. So let's take a look at both of these types of tests. First one comes to you from a 2022 Camry, the throttle position sensor wiring. So if we look at step A here, they say to disconnect the throttle body. Why are we doing that? Well, remember, we need to isolate the component being tested, and in this case it's the wiring. So disconnecting it from the throttle body, take a look at B. They say to disconnect the other end of the wiring, which happens to be connected to the ECM. So now with both sides disconnected, let's take a look at the spec. So they're saying on VC, which happens to be the throttle body side, and VCTA, which happens to be the ECU side, if we were to put the red lead and black lead on both ends of that wire, we should see below 1 ohm resistance, or in other words, good continuity. Let's take a look at the second test. The VTA wire happens to be the signal wire that comes from the throttle position sensor to the ECM. And on one end, that wire is called VTA, that's the throttle body side. On the ECM side, that's called VTA1. And they're saying on either end, now test that against body ground. Well, this wire should never see body ground. So in other words, if they're saying if I put a red lead on the wire, the black lead on the on body ground, I should see 10,000 ohms or higher. Or in other words, this is a short test. We're making sure that the wire is not shorted to ground. Okay, let's check out the next type of test. This is a resistance test with a specification. Again, coming to you from a 2022 Camry. This is the resistance spec for the throttle motor. And if we look at step A, they say measure the resistance according to the values. Between M minus and M plus, we should see anywhere from 0.3 to 100 ohms. So in other words, if we were to be over 100 ohms, that would be out of specification. Now, I do want to point out here that they say that the condition is 68 degrees. So temperature variations can also change resistance. Okay, let's see how to set up the meter. I have a black port or COM port for common ground, red port for the resistance, and red lead. Go ahead and hook up the red lead to the red port, black lead to common ground. As for the dial, we're going to want to put it straight to 12 o'clock for resistance, looking for that ohm symbol. Let's look at the display now. Notice it says OL, or out of limits. When the leads are not connected to anything and we cannot flow current from red lead to black lead, then it's going to say out of limits, or in other words, out of the ability of the meter. So much resistance that we can't even get any resistance reading at all. Okay, now pay attention to the qualifier. M ohms, big M. Now that we put the leads together, now it says, just has the ohm symbol. Okay, I think we're ready. Let's do some testing. Let's first do a continuity test. And in particularly, we're going to check continuity through the fuse. So just like we had to do before, we need to isolate that component. We don't want the thread of any sort of power going through this, so that we can actually use the meter and its voltage and current to get the correct reading. Okay, I'm just going to put the red lead on one side, black lead on the other side, doesn't matter. And I'm seeing a reading of 0.2 ohms. This is very common. We've got good continuity on this component. Okay, now let's go ahead and check the resistance based on a specification. Now the specification for this bulb happens to be less than 10 ohms. So between 5 and 10 ohms. Here I am isolating the bulb, making sure that I have no power. Of course it's shut off. So now that I have the component isolated, I'm going to use the red and black leads to go ahead and check the resistance of this component. Doesn't matter which one I put it in. And I've got a reading of 8.4 ohms. That's within specification. So here I'm going to go ahead and do a resistance test through the switch of this remote mirror, as well as through the motor itself. Now I've removed the fuse, so I have no power going through it. Sorry for the blurry screen, but as soon as I go ahead and actuate it, I get 83.5 ohms. Okay guys, that's it. To sum everything up here, I cannot emphasize enough to you on bullet point number 3 here, is that because we are sending voltage and current down the red and black leads of our DVOM, you must remove power and isolate the components that are being tested. Also, pay very close attention to those qualifiers. That qualifier that we can see right there on the right hand side, that can change everything. If all I see is a 1, Is that 1 ohm? Is it a K, so it's 1,000 ohms? Or is that a big M, meaning 1 million ohms? That drastically changes what you're seeing in a reading. So got to remember that portion of it. Last but not least, don't forget the 2 types of resistance testing. Are we checking for continuity? In other words, do I have the ability to carry current and voltage down this conductor? Or am I doing a resistance test with a specification? Don't forget that resistance and temperature go hand in hand. So if I have higher temperatures, my resistance could be a little bit higher or lower based on that temp. And that's it. Hope you've enjoyed it. If you have any more questions concerning resistance tests, feel free to contact your FTS or STS or comment in the comment section down below. Thanks.